Hello, in my thesis project, I just wanted to make sure the scene representation for the car is better. So when the car doesn't know what's in front of an obstacle, it can make a wrong prediction of path. And to fix this, we can estimate a bounding box around known objects, and hence we can know what's the boundary of those objects. But then such bounding box predictions are inherently not very perfect, and hence can create some problems like this. To solve this, we think that shape priors can help improve the bounding box estimation. So we use DeepSDF as the shape prior for representing cars, and DeepSDF can represent any kind of car shapes because it's trained on ShapeNet dataset, and this is conditioned on a latent code. Depending on the latent code, it represents different cars, and given a XYZ position in 3D space, it just tells you the SDF value for that car and the point. And SDF is nothing but the shortest distance between the any given 3D point to the surface of the car, represented by the SDF. We use pointer CNN to detect the bounding box of the car detected in the sensor frame. As you can see, we are showing the implicit shape represented by DeepSDF aligned with the bounding box. Here you can see that the shape of the car doesn't align well with the point cloud extracted from the detected car. And we want to use shape priors because by aligning the car shape with the point cloud, we can make sure we get a better bounding box which can faithfully represent the scene. And when the point cloud is aligning well with the shape, then they will have a zero SDF. So basically it's a minimization problem for SDF value. By minimizing SDF, we can estimate both shape code and the transformation because they are both parameters for the SDF. As you can see, by optimizing both shape and the pose of the car, we can align well and improve yaw, pitch, roll, and scale factors. And to look at it in a different way, we see that by detecting the car, which means by estimating x1, x2, x3, x4, the states of the car in different frames, we can use a simple detection, right? Detection as a conditioner, which is basically a single value. So x2 becomes d2, x3 becomes d3. But then if we associate them over time, we can have a more more constraints which can improve the estimation problem. But then since we have association over time, we can also say, okay, then this it's the same car, so they'll have the same shape code over time. By doing a joint optimization, we can improve the shape better than a single frame optimization. And this is the overall pipeline where we not just estimate shape and pose in the sensor frame, but also take it to the global frame, so we can see a simulation like this where the LiDAR is shown along with detected cars and the shape estimated. Thank you.